Okay, so in this problem, we are asked to classify the alcohol. Once we do that, we should be able to classify whether it's SN1 or SN2 reaction, and then we're supposed to draw the mechanism. So hopefully classifying the alcohol is easy. You should be able to look at the carbon-all-carbon, and for this reaction, say it's primary. Primary cations do not form. So because we have a primary cation, we have to say it cannot do SN1. It must be an SN2 reaction. With that in mind, we know we're going to have two steps. We're going to have the protonation step, which is the same for SN1 and SN2, and we're going to have the nucleophilic displacement step. So I'm going to redraw my alcohol. Of course, I picked the hard to draw 7-membered ring. That's going to be protonated by our acid. I'm going to draw in my lone pairs on everyone so we can keep exact track of where everybody goes. Okay, so in the protonation step, the lone pair on oxygen serves as a new covalent bond between oxygen and hydrogen. This bond breaks. Those electrons end up on the bromine. This forms the protonated alcohol, which is known as the alkoxonium ion. My oxygen only has one lone pair now. Its formal charge is plus. My bromine now has 4 lone pairs and has a formal charge of -1. In the second step, the two things I just drew come together to give our two products. So here's our alkoxonium ion again. I like to redraw so that I can make sure that each of my separate steps are balanced as far as charges and atoms. So in this step, the bromine attacks the carbon that holds the oxygen and forms a bond to it. This arrow here is your carbon-bromine bond forming. This arrow is showing this pair of electrons leaving the carbon and ending up on the oxygen. That gives me my alkyl bromide plus water. And here are the oxygen's 2 lone pairs, and bromine now just has 3 because the 1 pair is now on this bond, and here's the pair that went onto the oxygen from the CO bond.